Binary search tree is a special case of a binary tree. So here keyword is a search. Yeah? So binary search tree should be binary tree. That's a bottom line. So each node should have at least at the most two subtrees. That's what. And then additional property which is imposed on binary tree to become a binary search tree is as follows. That's regarding the data in each node. Remember that each node has three components. We have a data element, and then left pointer, right pointer. So the requirements of the data organization that makes a binary tree into binary search tree. The requirement is as follows. The key of the root is greater than the key in any node in the left subtree. So here we may have a left subtree here. That key in the root should be greater than any of the key data in the nodes of a left subtree. And then the key of the root is less than the key in any node in the right subtree. So if you have a right tree, right subtree, here you may have many nodes, then the key in the root should be smaller than any of those data in the node in the right subtree. The left and right subtree of the root are again binary search tree. So subtrees are also again binary search tree. What it means is that focusing on left subtree only, then this is the root of the left subtree, and the same requirements should be satisfied. The data in the root on this left subtree, the data on the root should be greater than any data in left subtree, smaller than any data on right subtree. Same thing is for right subtree. Considering this is root, the left subtree and right subtree, the key in the root node should satisfy the same condition. And then another one in the binary search tree is no two entries in binary search tree may have the same value. So mathematical concept, this is called the set, the requirement of a set. So there's no duplicated data. So actually, set is implemented by binary search tree in programming language. But this condition could be easily removed, so we are going to talk about that later. So for the time being, we are going to use a set concept in binary search tree. So with that, we can find several examples of a binary search tree with exactly the same key. So let me make the slide bigger. And here, so we have A, B, C, D, E, F, G with a same keys, the same data, and then we could make several different binary search tree. So binary search tree, the condition is that the value in the root should be smaller than, larger than any data on the left subtree, smaller than any data on the right subtree. So let me say that A, B, C, D, the alphabetic order is the value. Then on the left subtree, it should be all smaller than D, and then left subtree itself is a binary search tree. So considering this is root, left subtree, right subtree should have such requirements. Then right subtree of the root D, so E, F, G is all bigger, so that and then in turn, this is a root and the left subtree, right subtree. All the requirements are satisfied. Second one, root is E, left subtree, right subtree. And then this is root, left subtree, and right subtree, and so on. So recursively, you can verify the key value requirements. Here, this is a root, and then nothing on the left subtree. So this is a right subtree. On the right subtree, this is root. There is no right subtree. So this whole thing is a left subtree, and this is root, and left subtree and right subtree. So the key requirements are satisfied. Root is A, nothing in the left subtree. These are all on the right subtree. And then root in the smaller subtree, then no left subtree, and this is a right subtree. Root, no right subtree, this is left subtree. So all the key requirements are satisfied. So this is another extreme case. This is a root, no left subtree. This is a right subtree. Root of the right subtree, no left subtree. This is right subtree. And then again, no left subtree, and so on. So anyway, all of these configurations are binary search tree with exactly the same keys. So we are going to implement a binary search tree in C++. So to do so, we are going to do something like this. Here is an example of a binary search tree, and then data are just the words, and then dictionary order, alphabetic order is used as a value. So each node is represented by three elements: data, left pointer, right pointer, and then left pointer points to the top node of the left subtree and the like. And then the entire binary search tree is pointed by a pointer, so that this pointer is a representation of the entire binary search tree. But this pointer simply points to the top of the tree, which is called the root node. And then from that we can follow the links, pointers, to search to find the entire tree. So that is the way we are going to implement the binary search tree.